when we're doing accuracy assessments of classified images, one other statistic we look at is called the Kappa Statistic, or it's sometimes called K-hat because it's like a K with a little hat on top of it. The K-hat or Kappa Statistic is the difference between the actual agreement and the agreement expected by chance. For example, if you get 80% on a multiple choice question or multiple choice exam of 100 questions, that's good, but you could have just gotten a 50% by randomly guessing. So it's trying to account for how good a classification might just be if it were random. So a K-hat statistic of 90% means there's a 90% better agreement than chance alone. So it's kind of going on top of that. So these numbers tend to be lower than the overall accuracy assessment. So they're used to assess accuracy, but one of the nice things is now we can compare one accuracy assessment with another accuracy assessment, even if they're in different areas or looking at different categories. It's a better overall measure of how accurate the image classification is. So the K-hat statistic is the observed accuracy minus the chance agreement divided by 1 minus the chance agreement. So the observed accuracy is the diagonal of the error matrix. We just sum up the diagonal because that's going to be all the times it's right. And the chance agreement is a little more complicated. It incorporates the off diagonals, not just the diagonal down the middle of the error matrix, but the off diagonals, in order to get a better idea of what were the odds that the right category would be chosen just by chance. So it's a little more complicated of a formula, but it is an important statistic to look at because it's the most rigorous of those associated with determining the accuracy of an image classification.